Assalamu alaikum, grade 9s. Today we're going to go into the last section of chapter 8, which is 8.4, solving equations. And this is going to be dealing with word problems and more complicated equations like these three examples right here. And what we're going to be doing is we're actually going to be applying our equations into other situations and more complicated situations that we've had before. But before we do that, I want to bring your attention to something that it's posted on Google Classroom that is probably going to help you with this section specifically. So this is a document we titled "How to Translate English into Algebra" or "How to Translate Words into Algebra." And what it has here is it basically has common words that mean different mathematical operations. So some words that go with addition, for example, the sum of, plus, more than, increased by, total, altogether. Some words that go with subtraction, younger than, take away, diminished, reduced by, decreased by, or difference. Multiplication, product, the word of is there, we've learned of already. Twice, double, triple, quadruple, squared, factor of, as many as. These are all words that represent multiplication. Same with division and with equality, okay? So this document kind of puts all the words onto one thing and it's organized nicely for you guys. You also have on the next page steps to solving word problems. So it just gives you a step-by-step guide on if you follow these steps, you should be able to get through the word problem in a breeze. And then it gives you an example here using the step-by-step instructions that they mentioned above. Okay, so now that you have that, we can start on the actual notes for section 8.4. One thing I need you guys to make a note of and to keep in mind is that the difference between these equations and the ones you've been working with before is that you have an x on each side of the equal, whereas before you only had x on either the left or the right. But in these equations, you have an x on both sides. Now, the whole purpose of solving equations is to solve for x, which is the unknown variable. So the key thing that you want to be able to do here is you want to be able to move all the x's onto one side and then isolate it, which means that you have to put the actual numbers on the other side of the equal. So you want to move all the x's onto one side and all the numbers onto the other side. So you want to get x by itself on one side of the equal. You want to isolate it, okay? So you have to end up moving the x's in some way. So let's do our first question. It says solve 6x equals 3 bracket x minus 4. Now, there's actually two ways that you can solve this. So I'm actually going to show you both ways. So the first one, method 1. And then we will do method 2 after. Okay, so the first method, which is probably the easier one, is if you have 6x equals 3 bracket x minus 4, is you want to do, bed mass right away. So opposite operation. So not bed mass, SAMDEB. Okay, now there is subtraction in this equation, but it's inside the brackets. And with SAMDEB, brackets are left until the end. So the first thing you want to get rid of is this 3, which is being multiplied by the binomial. So the opposite of multiplying is dividing. So we're going to divide by 3 to cancel it out. And what you do to one side, you do to the other. Now 6x divided by 3 is equal to 2x, and you're left on this side with x minus 4. You can get rid of the brackets now because there's nothing else there. It's just what was in the brackets. And then now you continue with your SAMDEB, so subtraction and addition. We have x minus 4. So this is where it gets tricky. So you have x minus 4 here, and you have 2x here. So remember the note, I said you want to get all your x's, move all your x's to one side. So here, I can either move the 2x here by subtracting 2x, or I can move the 1x to the left by minusing x, because it's a plus x here. Now, the easier one to do is to just do the minus x, because if we subtracted 2x, we would be left with nothing on this side. So we'd have to kind of do double the work. So we're going to move the x to the left. So we want to move all the x's to one side. So this is a positive x, so we're going to minus x from this side. And what we do to one side, we do to the other. So these cancel each other out. 2x minus an x gives us just 1x equals, and then we're left with -4 here. So our answer is x is equal to -4. That's our first method to solve this. Method 2, when we have 6x equals 3 bracket x minus 4, some of you might be inclined to right away distribute the 3 like you learned in 8.3, which is fine as well. So when you distribute the 3, you get 6x on this side equals 3x minus 12. And then again, remember the note, we want to move all the x's onto one side. So since the 6x is already by itself here, we'll move the 3x to the left. So are we going to subtract 3x or add 3x? Well, we're going to subtract it because it was a positive here, right? If we rearranged this, it would be -12 plus 3x. So it's the same thing. We're just minusing 3x. Okay, these cancel, but what you do to one side, you have to do to the other. So 6x minus 3x leaves you with 3x's equals to -12. And x is still not isolated, so it's being multiplied by 3. So the opposite operation is to divide by 3 and cancel it out. And what you do to one side, you do to the other. So then x is equal to -4, which is the same answer we got in method 1. So you can choose whatever method for this kind of question that you like. If you find another one that works, you can use that method as well. So guys, math is nice because you don't have to follow one specific method, okay? All right, let's do the next one. So it says solve 2.6 plus 2.1x equals 1.5 plus 4.3x. So I want to make sure you remember this rule right here, okay? Move all the x's onto one side. So you want to move x's to one side and then the numbers to the other, the constants to the other. Okay, so here we have 2.1x and 4.3x. And then for our numbers, we have 1.5 and 2.6. So you can decide which side you want to move the x's to. Me personally, I always like to move the smaller one, just so that I deal less with negatives. So what I'm going to do is I'm going to move this 2.1 here to the other side by subtracting it, and I'm going to move my constants to the left. So I want to put all my x's on the right-hand side and all my constants on the left. So the first thing I'm going to do is move my 2.1x. So it's plus 2.1x. The opposite is minus 2.1x. This cancels it out. And what you do to one side, you do to the other. So here on the left, we're just left with 2.6 because these canceled. And then here we still have 1.5. And then when we subtract 4.3x minus 2.1x, we get positive 2.2x. So now we have a situation like, kind of like the first example. So we have all of our x's on one side, which is excellent, but now we want to isolate for x. So to get x by itself, we have to get rid of this 1.5. So it's positive 1.5, so the opposite thing is to minus 1.5. And that cancels it out. And what you do to one side, you have to do to the other. So 2.6 minus 1.5 leaves you with 1.1. Sorry, that's ugly. 1.1 equals, and then you're left with 2.2x on this side. And now all you have to do is to isolate x. So it's being multiplied by 2.2. So the only thing you have to do is divide by 2.2 now to cancel it out. What you do to one side, you do to the other. And then when you solve it, 1.1 divided by 2.2 is equal to 0.5. And we're just left with x here. So x is equal to 0.5. All right, you could have moved the 4.3 to this side and then the 2.6 to this side, and you would have ended up with negative on each side, which would cancel out to make it positive in the end. Okay, so that's the second question. We're going to do one more together, and then you guys are going to try one on your own. So this this question deals with two cases of distributive property, and then brackets and stuff as well. So it's a little bit more complicated. This is the most complicated you're gonna see it. So if you look here, here having brackets on both sides is the most complicated version, and putting fractions in there, it's just it makes it even kind of worse. So what we're gonna do is you can do two things. You can divide first the fractions, but then it gets a little bit complicated. So I'm just going to show you the distributive method way. So what we're going to do is we're going to distribute the fraction into each of their own brackets, okay? And distribute means we're multiplying. So 1/3 times 2x is 2x over 3, because remember, anything that doesn't have a denominator is over 1. And then 1/3 times -1, which is over 1, is -1/3. So when we distribute this, we get 2x over 3 minus 1/3. And then equals, and then if we do this side, 1/2 times 3x is 3x over 2. And then 1/2 times +1 is just 1/2, +1/2. So then this would be 3x over 2 plus 1/2. So again, guys, we want to move anything that has an x onto one side, and anything that is a constant or a number, we want to move to its own side. So in this case, I'm going to just move the x's to the left. Okay, so I'm going to subtract the 3x over 2 to move it to the other side. So here, 3x over 2 is positive, so I want to subtract 3x over 2 to cancel it out. And what I do to one side, I have to do to the other. So we have here 2x over 3 minus 1/3 minus 3x over 2 equals to 1/2. So we're going to simplify it, but first I want to get rid of the constant on this side. I want to move it to this side. So it's minus 1/3, so I'm going to plus 1/3 to cancel it out. And what I do to one side, I do to the other. So now we have 2x over 3 minus 3x over 2 equals to 1/2 plus 1/3. Now, remember, guys, the only way you can add or subtract any fractions is if you have a common denominator. And the common denominator between 3 and 2 is 6. So we're going to change all of these to be a common denominator. So this one is going to be multiplied by 2, the top and bottom. So that would give us 4x over 6 minus, this one's going to be multiplied by 3. So this would be 9x over 6 equals, again, this one's multiplied by 3. So 3 over 6 plus 2 over 6. This one's multiplied by 2. So now that they all have a common denominator, we can add and subtract on each side and simplify. So 4x minus 9x gives us negative 5x, and the denominator stays the same, equals 3 plus 2 is 5 over 6. Now you have two options here, okay? Option 1, you can cross multiply and divide. And then option 2, you can use the method that we've learned, which says that when you have a common denominator, you can just eliminate it and just solve the top, the numerators. So I'm going to just do them here. So method 1 is cross multiply. So negative 5x over 6 equals 5 over 6. Cross multiply. This gives us negative 30x equals 30. Divide by negative 30. Divide by negative 30. X is equal to negative 1. That's method 1. Method 2, I said when you have a common denominator, just eliminate them and solve the top. So negative 5x is equal to 5. Divide by negative 5. Divide by negative 5. So x equals negative 1, because 5 divided by negative 5 is negative 1. So in this question, the answer is x is equal to negative 1. So it's a lot of work, you guys, to answer one question. So that's why 8.4 is a little bit more complicated than 8.3, 8.2, and 8.1. So what I want you guys to do is I want you to pause the video and I want you to try out this problem on your own and then come back and check if you got the right answer. Okay, guys, for this one, the answer should have been that f is equal to negative 5. There are different ways that you could have solved this. I put two methods here. One, if you did a common denominator, and the second one is if you cross multiplied first. So if you did a common denominator, you should have seen that the common denominator is 4. So you'd have to multiply this one by 2. So multiply 2 by 2, you get 4. Multiply 3 plus 2f by 2, you have to distribute, which gives you 6 plus 4f. And now that you have a common denominator, you can kind of just cancel it out and just solve what's on top. So then you have 3f plus 1 equals 6 plus 4f. So I decided to move the f's to this side. So I did minus 4f minus 4f. I got negative 1f. And then I did minus 1 minus 1. So I got negative 1f is equal to 5. Or you would have gotten negative f is equal to 5. But the question isn't asking what's the negative variable. It's saying what is f? What's the variable? So you have to divide that by negative 1. And what you do to one side, you do to the other. Then you would get f is equal to negative 5. For the second method, I said to start you should cross multiply. There's more than two methods, you guys. Instead, you could have said, okay, I want to get rid of this divided by 4, so I'm going to times by 4, times this by 4 over 1, and then you can continue that way. There's way more than two methods to solve this, but this is the second method that I did, where you cross multiply first, and you'd have to distribute to each one, like you learned in 8.3, and that gives you 6f plus 2 equals to 12 plus 8f. And then when you solve it, normally getting all the variables on one side and all the constants on the other, you still get f is equal to negative 5. Okay, so now we're going to get into solving word problems using these types of equations. So setting up an equation and then solving a word problem. So in this first one here, it says in a jar of coins, there are 30 fewer quarters than dimes. And it says the amount of money in dimes equals the amount of money in quarters. How many dimes are in the jar? So that's what we're trying to find. So let's break down this question and see what they're really asking us here. So we have two types of coins here. We have dimes and we have quarters. Okay, and they're saying that the amount of money, that there are 30 fewer quarters than there are dimes. So, however, we don't know how many dimes there are, because that's what it's asking us. So we can make dimes x, and then it says that there are 30 fewer quarters than there are dimes. 30 fewer means that it's 30 less than that. If you take a look at the how to turn algebra words into algebra sheet, you'll see that the word fewer means subtraction. So whatever the number of dimes was, which is X, there's 30 fewer of them in quarters. Okay, so the amount of each coin is 30 amount of quarters is 30 less than the amount of dimes. Now, it says that the amount of money in dimes equals the amount of money in quarters. What they mean by this is that if it's saying that if we have, let's say $1 in dimes, then we also have $1 in quarters. Obviously, though, this looks a little bit different, right? Because $1 in dimes means we have 10 dimes. $1 in quarters means we have 4. So we have 10 for dimes and 4 for quarters in order to make $1. So there are different amounts of each in order to make that value of $1. But the value is the same. So I'm just going to erase this so we don't get confused. The value is the same. So we know that a dime is 10 cents and a quarter is 25 cents. And so the dime in dollars is 0.10 and the quarter in dollars is 0.25. And so we're going to do is we're going to set up an equation. So if, like I said before in the example, when I said that we have 10 dimes, that is equal to $1, how did we get that? Well, we took the number 10 of dimes and we multiplied it by 10 cents. And when you multiply them together, you should get 1, which is $1. So the amount of dimes times the value of the dime gives you the total amount in money. Okay? So in order to get the total amount in money for these, we have to take the value of each coin times the number of each coin that we have. So that would give us the amount in money. So this is value times the number of coins. So how many dimes do we have? We have X number, and then the value of each one is 0.10. And for quarters, we have, each one is worth 25 cents, and we have X minus 30. I flipped them here because we always want to have the monomial on the outside and the binomial in the brackets. For this one, it doesn't really matter the order because they're both monomials. And we know that this amount for both of them is equal, okay? Because the amount of money in dimes equals the amount of money in quarters. So X times 0.10 is equal to 0.25 times X minus 30. And now all you have to do is solve, because this is now something that we've looked at before. X times 0.10 is 0.10x. And then for this, we have to just distribute. So this would be 0.25x, and then 0.25 minus 30 is, if you give me a sec, 7.5. Okay? So now here we have a situation like we've done in the previous page where we have x's on both sides, which means we have to get them onto one side. So what we're going to do is we are going to subtract 0.25x to cancel it out here. But what you do to one side, you do to the other. So then this leaves us with negative 0.15x equals negative 7.5. And now to get x by itself, you divide by negative 0.15, divide by negative 0.15. And then this gives you, first of all, the negatives are going to cancel out because a negative divided by a negative is a positive. And that makes sense because how could you have a negative amount of coins? So when you divide 7.5 by 0.15, you get 50. Okay? So x is equal to 50. Let's see if that answers the question. So what did x represent before? Well, it represented the number of dimes. And the question asks how many dimes are in the jar. So, yep, the number of dimes is X, and that is equal to 50. Now, if it asked us how many quarters are in the jar, all we would have to do is take this 50 and subtract 30 from it. So it would be 50 dimes and 20 quarters. And if you check if it works, it says the amount of money, right, in the dimes equals the amount of money in quarters. So let's check if that's true. 20 quarters at 25 cents each. 20 quarters at 25 cents each is $5. And 50 dimes at 10 cents each is also $5. Okay? So that's how you can check if you did it properly at the end. You can check if they actually do equal each other, which they do. So that's how you know your answer is correct. So this is kind of a complicated word problem, but you have to kind of take it step by step. Whenever you have a coin question, okay, if you follow this chart method, you will get your answer all the time. So always make a chart, okay, and say, okay, how many of each coin do I have? What is the value of each coin? And then the amount is multiplying these two together. And then here you have to decide, are they going to be equal to each other, or are you going to add them together to get some kind of other total? Depends what the question is telling you. In this case, it tells you that they are equal, so we just equal these two equations. Okay, so I want you guys to try a coin question using the same process that we just did. So pause the video and use the same method, making a chart of the value, the amount, and the number of coins, and then set up your equation and solve. All right, guys, so for this question here, it's a little bit different than the first one because it says the number of dimes and nickels is the same. So we have an equal amount. So if we have X dimes, that means we have X nickels as well. If the value of each of the coins in the bag is $2.85, so that's saying all of them together is $2.85. So what you're going to have to do is you're going to have to add them up at the end. How many nickels and how many dimes are there? So we know that they're the same number, which is X. We know that dimes are 10 cents and nickels are 5 cents, which we always put into dollar form because this is in dollar form right here. And then the amount in money, we just multiply them. Now, once you get these two amounts at the end, you have to figure out, am I going to equal them or am I going to add them and make them equal to something else? And in this case, they're being added together, and together they're going to equal $2.85. So the values are not equal to each other, but in total, they equal to $2.85. So 0.10x plus 0.05x is 285. Combine your like terms, because they both have x. That gives you 0.15x equals to 285, and then you just divide by 0.15 to solve for x, and you get that x is equal to 19, which means that you have 19 dimes and 19 nickels because they have the same amount. Now, guys, you don't have to use this method if you can do it from your head right away, if you can get to this point. That's perfectly fine. This is just a way that if you're struggling with this kind of question, you can take it step by step and solve it. Okay, so these are the two types of coin questions you can have, where they are going to be equal to each other, or you're going to have to add them and make them equal to a different amount. So if you guys can go over these and make sure you understand them, you'll be able to do any kind of coin question. Again, you don't have to use the chart, but it does help. Okay, let's look at another type of question. This is a type of question that deals with money, but it's not with coins specifically. So in this kind of question, it's about, saving money. So here we have two people, Fatima and Jihan, and it talks about how much money that they're saving. So it says Fatima has $35.50 and she saves $4.25 every week. Okay, so she starts off with this much and she's saving $4.25 a week. Jihan starts off with $24.25 with a lower amount, but she saves more each week, $5.50 a week. And then it says, in how many weeks will they have the same amount of money? Okay, so you want to kind of set it up again. So we have Fatima and we have Jihan. So Fatima starts off with $35.50. Jihan starts with $24.25. And they're saving money. And saving money, does that mean that they're adding money to their bank account or they're taking away from their bank account? Well, saving means you're adding to your bank account. So every week, Fatima's adding $4.25 per week, which we don't know how many weeks we have, so we're just going to put times W. So if it's 1 week, just $4.25. If it's 2 weeks, $8.50, and so on and so forth. The same with Jihan. She's adding $5.50 per week to her amount, to her bank account. So it's asking, in how many weeks will they have the same amount of money? So what you want to do with these two expressions is make them equal to each other, because we want to know when will they have the same amount of money. Because the amount of money Fatima has is her starting amount plus how much she's saving. And the amount of money Jihan has is her starting amount plus how much she saves. So how much money does she have? Well, Fatima has $35.50 plus her savings. And Jihan has $24.25 plus her savings. And it's asking, when will they be equal to each other? When will they have the same amount of money? So now we set up our expression, our equation. All we have to do is solve for our unknown variable, which is W. So that means we want to get all the W's on one side and all the constants on one side. So I'm going to put my W's on the left. So I'm going to minus 5.5 to cancel it out here. And what I do to one side, I do to the other. Now, I want to remind you guys that you can only subtract like terms. So that's why I'm putting the 5.5 here under the 4.25W, because these are what are being subtracted. I can't minus 5.5W from 35.50 because they're not like terms. So that's something that you have to make sure you remember. Okay, so here we still have this 35.50, but once we subtract 425 minus 5.50, we get negative 125 W's. And here we still have 24.25. Now we move the W's to one side. Now we want to isolate it. So get all the constants onto the other side. So this is positive 35.50. So I'm going to subtract 35.50 to cancel it out. And what I do to one side, I'm going to do to the other. So 35.50 minus 24.25, that is going to equal to 11.25, and it's negative. And this is negative 1.25 W. Now, we still have to continue isolating for W, so it's being multiplied by negative 1.25. So the opposite is to divide. And what you do to one side, you do to the other. And again, you guys, what's going to happen first is that the negatives are going to cancel, which makes sense because the number of weeks can't be a negative number. And then you divide the actual numbers, and you get W is equal to 9. So in 9 weeks, the amount of money they have will be equal. Okay, so 9 weeks is our answer. All right, guys, so our last type, so we did coin questions, we did savings questions. Our last type of word problem that we're going to talk about is distance or traveling questions, and it's our last one for the topic. So here we have example. So it says a car leaves Edmonton traveling at 40 kilometers an hour, and then a second car leaves Edmonton 1 hour later traveling at 60 kilometers an hour. And the question asks, how far from Edmonton does the second car overtake the first? So one thing we have to understand is that the word overtake basically just means it catches up to it. So overtake, it means it's going to pass it, but in order to pass it, first it has to actually catch up. So think of it as catching up. And if it's going to catch up to it, that means that their distances are going to be equal to each other. Okay, so another thing that you have to understand before you start this problem is the formula for distance is equal to speed times time. So we're dealing with three things here: distance, speed, time. So you have to kind of know this formula. If you're given a question like this on a test, you will be given the equation. You just have to kind of understand how to use it. So again, we're going to start by setting up our information. So we have car 1 and we have car 2. And what I'm going to do is I'm going to put these variables here on the side because that's what we're dealing with. So speed, time, distance. Okay? So car 1 is traveling at 40 kilometers an hour. Car 2 is at 60. So that's the speed of those cars. For the time, we don't actually know the time that it traveled for, because here time doesn't mean like the time on a clock, like 1 p.m., for example. It doesn't mean like that. It means like how long has the car been traveling for? Okay, how long is the travel? We don't know how long the travel is, but what we know is that car 2 leaves an hour later than car 1. So there's two ways you can do this. You can say that car 1 is X and car 2 left an hour later, so X minus 1. Or, so it's been on the road for an hour less. That's what this means. So the other way you can do it, which is my preferred way, is that since car 1 left an hour before, I'm going to make it X plus 1, and car 2 is just going to be X. That way I don't really deal with negatives here. So remember that with time, guys, it's not the time on the clock, it's how long the travel is. So car 1 has been on the road an hour longer than car 2. Okay, that's why it's X plus 1. The other way you could do it is make this X and make this X minus 1, because it's been on the road for an hour less. But you can choose whichever method you want. They will both get you the right answer. Okay, the question asks how far away from Edmonton does the second car overtake the first one? So it's asking for the distance, okay? And we know from the formula that I gave you that distance is equal to speed times time. So for car 1, it's 40 times X plus 1, because it's the speed times the time. And for car 2, it's 60 times X. Now here we have our equations at the end. What do we do with them? Do we add them together and make them equal to something else? Or do we make them equal to each other? Well, here we are going to make them equal to each other because it's asking us when will car 2 overtake car 1. So when will car 2's distance be equal to car 1's distance? When will they cover the same ground? So I'm going to rewrite it here and make them equal to each other. So we have 40 X plus 1 equals 60 times X. So now you're going to solve. I'm going to start by distributing. Okay, so 40 times X is 40X, and 40 times 1 is just 40, and here we have 60X. Now we want to get all of our variables onto one side and all of our constants onto the other. So I'm going to do minus 60X, minus 60X. Again, these cancel, and I'm lining up the X's because they're like terms, and I'm only subtracting it from the X. So here we have negative 20X plus 40 equals, there is nothing left here, is 0. So this is another way that you can solve it. The other way, the easier way, is that if I should have just moved the 40X to this side. But I wanted to show you another method to solve. So now the X's are all on one side. I want to get my constants on the other. So I want to subtract 40, subtract 40. These cancel. So now we have negative 20X equals negative 40. And then to solve for X, divide by negative 20, divide by negative 20. X equals, the negatives cancel. 40 divided by 20 is 2. So we're not done yet because we solved for x. X is equal to 2. But what did x equal to in the original question? The x is equal to the time of car 2. But is that what the question asks? How much time did it take to overtake? No, it asks how far the distance, so how far away they were, okay? So what we're going to do is we're going to plug this x into our any one of our distance formulas to figure out how far away they were, okay? And I'll show you how it works with both. So here we have 40 times x plus 1, and we learned that x was 2. So 40 times 2 plus 1, this is 40 times 3, which is equal to 120. So here, if we plugged in x, we would get 120 for the distance. And let's look at if we plugged it in here. So 60 times x was 2, 60 times 2 is 120. So it doesn't matter where you plug the x into, either way you're going to get that the distance was 120. So here the answer would be at 120 kilometers, car 2 overtakes car 1. Okay? So it's not enough, guys, for word problems to just solve for the variable. You always have to go back and say, okay, what we solved for x, but what did x equal? What did it represent before? So here it represented the time of car 2, which is not what the question asked for. It asked for the distance. So we have to go back and plug it in to find it. All right, guys, I want you to pause the video and try out this traveling question, and then come back and check your answer and see if you did it correctly. One thing I want to say, though, before you do the question is here it tells you 4 p.m. and 5 p.m. Remember that the time, is not a number on a clock, okay? So you can't put 4 p.m. and 5 p.m. here. It doesn't work like that. The time is not the number on the clock. It's how long the travel was. So if this is 4 p.m. and this is 5 p.m., this would be, x, and then this would be an hour later, which is x minus 1, because they've been on the road for an hour later. So that's something to keep in mind before you start this problem. So pause the video. Please try your best to do it on your own and come back and check your answer. Okay, guys, so I set up the table with the speed, time, and distance. Remember that distance is equal to speed times time. And now I'm gonna put it together and solve it. So I put their speeds, their timings, because Khalil was on the road 1 hour longer than Omar was. So he has a x plus 1, whereas Omar is just x. And then the distance is them being multiplied together, the speed and the time. Now, in the previous question, we made their distances equal to each other because they were going to overtake each other and meet at the same place. This question doesn't say that they're going to be at the same place. It says, when will they be 316 kilometers apart? So the distance between them is 316 kilometers. In this case, instead of making them equal to each other, we're actually going to add them together, because we're going to add their distances together, and their total distance between each other has to be 316. Okay, so this is Khalil's distance, and then Omar's distance. Okay, and the distance between them has to be 316. Okay, so like if this was Khalil and this is Omar, okay, the distance between them is 316. So you would add up their distances. Like if this is Edmonton, and you can see here that they traveled in opposite directions, west and east. So they're moving away from Edmonton in opposite directions. And so Khalil, his distance is this way, and we don't know what his distance is. And Omar's distance is this way, and we don't know what his distance is. But together, their distances have to equal to 316. So that's why we add up their distances, because they're in opposite directions, and their total distance between each other has to be 316. So now that we have our equation, we can actually solve it. So here we're going to start off doing distributive property. We get 116x plus 116 plus 84x equals to 316. And I'm going to combine my like terms. Okay, so 116 plus 84. Here, the x's are on the same side, so you're just combining the like terms. When you add them together, you get 200 x's plus that 116 that's still there equals to 316. And then you want to isolate for x, so you're going to do samdeb. You're going to subtract 116 from both sides. So you get 200x equals to 200, because 316 minus 116 is equal to 200. And now you isolate x by continuing your samdeb. You divide by 200, and you say that x is 1. Now, what does this x is equal to 1 mean? We're going to go back to this thing. What did I make x equal to? Well, I made that equal to Omar's time. So after, at Omar's time, x will be equal to 1. So basically, it's asking at what time will they be 316 kilometers apart. And that time will be here. We would just take the 1 plus 1, and that would be 2. So 2 hours later, after Khalil leaves Edmonton, they will be 316 kilometers apart. So at 5 p.m., Khalil left at 4. So 4 plus another 2 hours, that would be 6 p.m. And here he leaves at 5 p.m. and after 1 hour, that's also 6 p.m. So at 6 p.m., they're going to be 316 kilometers apart. Okay, so after one hour after Omar leaves, they will be 316 kilometers apart. And Omar left at 5, so 1 hour later is 6. And then Khalil is 1 plus 1, which is 2. So 2 hours after 4 is also 6. All right, guys. 8.4 is really, really long. These kind of questions are complicated, but they are the most complicated that you're going to see. Your textbook questions aren't that bad. So what you're going to do is I want you guys to try out these practice questions in the textbook. So from on page 326, questions 6 to 20, but only the even numbers. So 6, 8, 10, 12, and so on. And then questions 26 and 27. These questions will give you a better idea of the kind of word problems that you need to be able to solve. Okay, the ones in the notes are definitely the harder ones that you're going to have. These ones should be a little bit easier for you if you follow the how to translate words into algebra and you just do it step by step. Okay, make sure you guys get this done soon, and then you guys attend your help sessions to ask your questions, because this will definitely be the topic where you have a lot of questions. Okay, that's everything, guys. That's the end of chapter 8. We're all done. Wrapping it up with a really hard topic, but we are done. And yeah, if you have any questions, just let us know. That's all for today. Salam.